is the contact and via. Contact is the point where the diffusions and polysilicons have to be connected, and via is a connection made between two metal layers. Both are done using metals. Usually for via, tungsten is used, and for contact, aluminium is used. If you look at this diagram, this is metal 2 and metal 1, which is connected through the via, and either the metal and polysilicon or metal and diffusion is uh, connected through something called contact or contact cut. Now, there are three different ways in which contacts can be done. That is uh, polysilicon and diffusion connection. Basically, contact means it is connecting the polysilicon and diffusion. There are three ways in which it can be done. That is polysilicon to metal, then from metal to diffusion, or buried contact or butting contact. The first one, polysilicon to metal and metal to diffusion. In this 2 lambda into 2 lambda area, that is the area, in that area the oxide layer is removed till the polysilicon or the diffusion layer is seen. Then metal is deposited on that, and this metal will connect the polysilicon and the diffusion. This polysilicon, if you see here, this is a polysilicon and diffusion. This metal is connecting the polysilicon and diffusion. It is in between the polysilicon and diffusion. Next one is the buried contact. In this buried contact, in the area of 2 cross 2, the oxide layer is removed till the bottom silicon wafer is seen. Then on that the polysilicon is deposited. Then in that 2 cross 2 area, and upon that diffusion is and that is N or P diffusion is impurities are diffused into that. This gives a connection between polysilicon and diffusion in that particular area. Here there is a direct connection between, if you look at the diagram, there is a direct connection between the polysilicon and the diffusion. There is no intermediate metal. Polysilicon and diffusion, they are directly connected. This is more reliable and more economical connection compared to the other two. Next, coming to the butting contact. In this butting contact, we see that the polysilicon and the diffusion is connected using metal, whereas the polysilicon is here, the diffusion is here. The metal connects you. Again, you have to open an area of 2 cross 2 here, and also 2 cross 2 lambda, 2 lambda into 2 lambda, 2 lambda into 2 lambda here, and you have to pour metal. These metal will come in, go in this area, that is 2 lambda into 2 lambda area here, and 2 lambda into 2 lambda here, and make a connection between these two. The difference in the first one and this third one is, here the metal, it is connecting these two which are far apart, whereas in the first one, if we see, it is the polysilicon and diffusion is here, it is in between these two. The most reliable of these three of them is the buried contact. Now coming to the contact rules, and this is the active area, the contact area, which has to be 2 lambda into 2 lambda into 2 lambda, and it will extend up to 4 lambda into 4 lambda. The outer is the 4 lambda into 4 lambda. This is the metal one, and this is the polysilicon. Polysilicon, metal 1 to polysilicon or metal 1 to diffusion. This is called the contact, and this is the active contact region, which is 2 lambda into 2 lambda extending up to 4 lambda. This entire, the bigger square is 4 lambda, the outer square is, this one is 4 lambda into 4 lambda, and the spacing between two contacts should be 2 lambda. Here also the spacing has to be 2 lambda. And if it is a via, as we said, it is connecting two metals, metal 1 and metal 2 is connected using via. The spacing between via and a contact will be 2 lambda. Here we can see, if we are coming to this here, again, this is the buried contact what we have here, and this is the butting contact. Buried contact, it will extend here, this contact has to extend above by 1 lambda, and here it has to extend by 2 lambda. On the either side here also it is extending by 1 lambda. and here in the top we see it is getting extended by 1 lambda on the either side. Here this is if we look at this is a active area. The inner blacker, this has to be 2 lambda into 2 lambda. This entire thing should be 4 lambda into 4 lambda. This is the active contact area and this is the 4 lambda outer one. The spacing between the contact has to be 2 lambda. The spacing between contact and wire has to be 2 lambda. Next, coming to the CMOS lambda rule. As we have seen, we have already seen how to draw the layout for a CMOS inverter. And while studying the fabrication also, we saw that this entire CMOS structure is developed on a single substrate, which will either have a N-well or P-well. If it has a P-well, it is having a P-well, it will have a P plus layer or P plus mask. That is, here in a P-well, we have N diffusions. Along with the N diffusion, we will have to have P diffusion. That is represented by a P plus mask or P plus layer. Here on this is PMOS, which will have P diffusions. Along with the P diffusions, it will have one N layer. So that is represented by N layer. This N layer has to be connected to VDD, whereas this has to be, along with this, it has to be connected to the VSS or ground. So this is the monochrome diagram, color diagram. Here this is the P well what we have, and this is the that is the P plus mask. This is the drain and this is the source which is connected to VSS. This is your pull-up transistor, PMOS transistor. This will be the source which is connected to VDD. The drain of PMOS and drain of NMOS are connected as output. Along with this, there is one more N diffusion here which will be connected to VDD. The same for this, the rules will be here. That is, we have the P well. This P well here. We are discussing about the now VSS connection. That is, the pull down will have N transistor which will be in the P well. So this is the outer dotted line represents a P well, and this is the P mask. As I said, P mask will be the area where P diffusion is done in the P well. We have N diffusion. Along with that, we should have P diffusion. So that is represented by the P mask. The distance between the P well and your P mask will be 1 lambda, and the distance between the VSS metal and this P mask will be 2 lambda. The distance from this contact region, that is outer contact region, contact area, to the P well will be 3 lambda, and that here again, that this, as I said, between P well and P mask will be 1 lambda. Coming to VDD connection, in the VDD connection, if we see here, the distance between this, that is from the contact, active contact, this region to this is 3 lambda. From here to here it will be 1 lambda, because from here to here it is 1 lambda. 1 lambda, 1 lambda, 2 lambda, totally 1, 2, 1, it will be 4 lambda. So this region from here to here it is 3. From this end to this end it will be 2 lambda. Here again this should extend up to above 2 lambda. So this is for a PMOS, CMOS lambda rules. Then here this is for a PMOS again. Instead of having separate contacts like this, it can be merged. It can be merged and single, because both of them are anyway connected to VSS. It can be shown together like this. Here also, because both of them are connected to VDD, it can be connected together and connected to VDD. Again, in that case here, the well has to be extended 3 lambda below the metal, and here also from the diffusion it has to be extended beyond 3 lambda, and the difference between this, that is from this end to this end, it is 3 lambda. And here the spacing between the well and mask, as I said, it is 1 lambda. And again, the same coming to the VDD connection. here from this end, that is the midpoint from here, the midpoint of these two connections, from here to the diffusion part, here it is 4 lambda, the spacing is 4 lambda. From the diffusion to the p mask, this is a p mask, this will be 2 lambda. It should extend above this metal by 2 lambda. So, and if we have two wells, this is one P well and this is one P well. If the two wells are connected to same voltage or VDD, then the minimum spacing has to be 2 lambda, else the spacing has to be 6 lambda. This is for a P mask. P mask, here the distance between two P mask has to be 2 lambda, and between the uh, P mask and between the end diffusion it has to be 2 lambda. Between P mask and polysilicon it has to be 2 lambda. So the separation is given here, that is between P mask and the end diffusion and P mask and the polysilicon it has to be 2 lambda. Distance should be 2 lambda, and the P mask it should extend 2 lambda from the contact region. On the either side it should be 2 lambda, from here it should be 2 lambda. So this is about the CMOS. If we see here, it shows that how the contact, that is the well, what is the distance from the well from the mask. Here if we see what from the mask, this is the well, what is the spacing, what is the minimum spacing from the mask to the well, from either direction what should be the minimum spacing. This is the micron based rules. In micron based rule, till now we were discussing about lambda rules. In micron based rules, if we see, all the dimensions are given in terms of micron values. Either the width is 3 micron, the spacing, if we have, you can see here it is 2 micron. Here the polysilicon, the width should be 2 micron, the metal width should be 2.5 micron. As we told you initially, in micron rules we have point values, well as lambda it is a whole number. Again the spacing between the metal is 2.5 micron. So similar to how we have lambda rules, similarly we have the micron rules. Even for an N transistor, this is P transistor, that is the transistors, this is the end diffusion and this is the polysilicon. The diffusion in the lambda it should extend from the polysilicon by 2 lambda. Here it has to minimum extension should be 2.5 lambda. The width should be 3 lambda, and minimum extension here on this, that is polysilicon, should extend by 1.5 lambda. Similarly here also for a P transistor should extend, P diffusion should extend by 2.5 lambda, whereas polysilicon should extend by 1.5 lambda. Even contact, that is what is the minimum contact, is 2 lambda into 2 lambda. It should extend up to 2 micron to 2 micron. Here it should extend up to 5 micron to 5 micron. Here all these values, 2.5 micron, this is 3 micron, 2 micron, 3 micron. So all these values are given in terms of micron designs. Where in lambda, all these values are in lambda. Here it is in like 3 micron, 3 micrometer, 3 micrometers. So this is about the design rules.